Goodbye, spooky. And hello, chilly November. November, whose name, by the way, is derived from the Latin novum for 9, and of course is the 11th month of our modern Gregorian calendar, thus demonstrating that naming is hard and versioning is important, two problems we still struggle with centuries later. Which means this week we talk with Peter Klimek from Imperva about strategies for securing APIs and how newer design patterns hold more promise for security, but still have plenty of problems to solve. In the news segment, a webhook turns into RCE, a checklist for minimum security, an assessment of end-to-end encryption, privacy engineering specialties, and more. Turn to 11 and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Contrast Security enables organizations to secure their applications from development to production. By embedding security sensors within software, Contrast automatically and continuously detects vulnerabilities in both custom and open source code while developers write code, providing them with context-specific how-to-fix guidance for easy and fast remediation. At the same time, by identifying only true vulnerabilities that pose risk and eliminating those that do not, Contrast empowers developers and security teams to prioritize and focus on only those vulnerabilities that matter. Learn how Contrast can help you secure your applications from development through production at securityweekly.com/contrast. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today. Is your mobile app really secure? New vulnerabilities pop up every day, and malicious actors look for easy targets on app marketplaces to exploit. Securing your app's valuable IP and data is critical. GuardSquare's security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection prevent reverse engineering and automatically detect tampering, making your app a difficult target for attackers. Learn more at securityweekly.com/GuardSquare.
This is episode 172, recorded November 1st, 2021. I'm your host, Mike Shima, and while I was too sad to see October go by, I'm always happy to welcome Mr. John Kinsella. Hello, John.
And I'm happy to be here. We've got a special treat for our guest this week because we're going to do a 2-hour episode focusing on what is CryptoCoin.
Take it away, John. Surprise. While we get up and while we get everything ready for this special non-April 1st episode of November 1st CryptoCoin by John, let's go through some advertisements. InfoSec World 2021 is proud to announce its keynote lineup for this year's event. Hear from Robert Herjavec, plus heads of security at the NFL, TikTok, U.S. Department of Homeland Security, Stanford University, and more. Plus, Security Weekly listeners save 20% on digital pass registration. Visit securityweekly.com/ISW2021 to register now. Then you can join us for our next live webcast on November 4th, coming up soon, to learn about pragmatic steps to reduce your software supply chain risk. Then join us November 11th to learn the key insights and takeaways from the 2021 OWASP Top 10. Who knows, maybe it won't have cross-site scripting on it anymore. Visit securityweekly.com/webcasts to save your seat. And don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. While John is continuing to get his 2-hour presentation ready, I'll introduce our guest, who's Peter Klimek, the Director of Technology with the Office of the CTO at Imperva, a market leader in edge, application, and data security. Klimek helps global customers protect their applications, data, and websites from security threats through all stages of their digital journey. Prior to Imperva, he held roles at Kaspersky, TransUnion, and Zebra Technologies as a solutions architect, security analyst, and an engineer. Hello, Peter. Thank you for joining us.
It's a pleasure to be back on the show.
And we're happy to have you back, indeed. And last time we, in fact, chatted about some API security. And I don't think we finished because there's plenty more API security to talk about this time. But I think we're also going to perhaps go in a slightly different direction. Talking once again about the challenges from customers, what you see them running into. But when we chatted a little bit before this, there were some interesting things that you had noted about some of the design patterns that are changing and the good and the bad. And since we have to stick to the rule of three, the ugly as well that might come through, to talk about kind of the difference between as we're moving away, or maybe companies are starting to move away from maybe RESTful types of APIs and going into GraphQL-based APIs. So that's a little bit of a teaser, but as we start that off, what have you kind of seen as new challenges or the challenges that companies are still struggling with in terms of API security?
Yeah, I think it's helpful to just first level set on just some of the reasons why we see APIs being everywhere. They've always been around, I think, in application development, really from the early 2000s. A lot of organizations were adopting web services. And something that we talked about quite a bit in the last podcast was talking about this shift in migration to more serverless and microservices and everything around those lines. And if you think about the way that those microservices communicate, they of course are going to use APIs as really that communication language. But above and beyond that, ultimately what we've seen is its proliferation of mobile applications, IoT devices. All of those are using APIs exposed externally. We have changes in web development technologies. So over the last few years, technologies like React and Angular, basically they make up what you call single page applications in architectures for those, as well as newer Jamstack architectures, which is just a combination of JavaScript APIs and Markdown. So the A in Jamstack is API. And then last but not least, of course, you have entire businesses that were built on just exposing APIs. Probably the most common and prolific I could really kind of name off there was like Twilio and SendGrid and some of the other services, which were just really going and exposing APIs externally. And so really the biggest thing is we just started seeing a lot more of them being developed and exposed externally for one of those four reasons, really.
Yeah, and I think, I'm going to guess that a lot of the basics are still important. Where are your APIs? How do you enumerate them? Where are all of your endpoints? Have some input validation, things like that. But it sounds like there's possibly, well, let me ask a more open-ended question. Is that it? Are there newer and different, more interesting types of problems that companies and organizations are still running into as they are shifting to a very pure type of API type of offering?
Yeah, definitely. This was actually, I think, one of the more interesting things just for me as, someone who's been in security for such a long time, was even seeing how long it took OWASP to come out with an API specific top 10. For years and years and years, basically everyone kind of took the position of, let's just saying, well, APIs are actually just like web applications. They just don't render and display HTML pages. So yeah, the OWASP top 10 is kind of good enough for this. And it really, I think, took that proliferation, that explosion of APIs, as well as really kind of the time of seeing how attackers were starting to go and actually target specific APIs, where they kind of took a step back and said, okay, well, wait a minute, maybe we need to go and actually come up with a new API specific top 10. But at the same time, when you went and actually looked in it, sure, there's lots of new names. There's like broken object level authorization, broken function level authorization, all sorts of different types of vulnerabilities. When you kind of map them out to the original one, what you saw was about 70% of them were effectively a rehash of what we've pretty much previously have done. But then the other 30% were approximately new. And really some interesting ones to kind of dig into there, as well as we started to see the strategies that teams are using to actually try to protect against those.
Yeah, and some of those, we've talked on the show quite a bit just about the authentication part of APIs, because that's where organizations are trying to figure out, here's a token. Are we handling the token correctly? Are we protecting the secrets for that token correctly? And we start to get in that alphabet soup of whether it's just JOTs, those JWTs, or other types of token schemes. And hopefully what you've seen with customers is that they are actually using either JOTs that are well configured, or even sort of the signed requests. That's the model that AWS has, rather than just HTTP basic or HTTP digest. Has the authentication at least gotten a little bit better there?
Yeah, I think by and large, the authentication schemes themselves, if properly implemented, tend to be pretty good. And it's really going to depend on your use case. So if you're using a consumer mobile application or even like an enterprise application where you have a user that's basically connecting into it, there's a good chance you're probably going to be relying on something like OAuth 2 or SAML as really kind of that mechanism for at least validating or authenticating the end user. And so ultimately, those types of protocols and those types of systems tend to work fairly well. I think the bigger challenge with APIs always ends up being more of the machine to the machine communication. And in particular, one of the big things about machine to machine communication is that those tokens and the IDs themselves, or the actual secrets between them, they often get stolen. There's plenty of instances where developers have accidentally just checked those tokens into source control, and Git never forgets. And so it's really easy to go back and find in the Git log basically those instances of the keys that are in there. Or people are storing them as environment variables, and those environment variables are getting filtered out basically in one way or another. And so it's not necessarily the authentication mechanism that I think is a big challenge. It's the tokens themselves. And relying on short-lived tokens that you have to refresh, those are some of the strategies that we ultimately will see being used for solving authentication for APIs.
Nice. And hopefully the story behind managing those tokens, managing those secrets is improved, whether we're talking about just cloud native types of environments, all the cloud service providers having APIs of their own to be able to manage that, or at least expectations that here is a mutual TLS, here's just a mutual token to demonstrate authentication or demonstrate that identity, so that, like you said, attackers don't necessarily need to get root, they just need to get access to a system. And if it's a API token, game over, because then they can get into the service, into the data.
Absolutely. And this is ultimately, I think, where APIs become a little bit more interesting to us as an attack vector themselves, because one of the things you have to really kind of consider about an API is that it's by definition really kind of designed as being a data query language effectively. It's a data query language that you happen to be exposing and accessing over HTTP, but the core thing is that it's actually exposing the underlying data, and it's giving developers a really easy way to be able to query that data and access it. And so this is part of the reason why we saw the changes in the OWASP API top 10 to be really focused on around authorization, because ultimately, by giving and exposing a query language externally in something specifically that's also stateless, it made it very easy for attackers to go in and start actually trying to look and query resources that they shouldn't have been able to look for. And so I think that's ultimately one of the bigger challenges that we'll see, at least initially, with a lot of APIs, and where a lot of attackers tend to look.
So that's a really interesting way to think about it. And one of the things I've been trying to wrap my head around for the last few months, or I guess longer, but if you think about GraphQL, that I think in almost everyone's mind is most definitely a query language that's been exposed over some sort of HTTP port, HTTP protocol. But I don't know if I'd made that leap myself to actually, I don't know if I'd say admit that a standard JSON API is actually more of a query language. I think there's things you can do in there that aren't necessarily data related, but I think you're probably right. Then that's what we're using it for more and more and more nowadays.
Yeah. And the way that I've kind of rationalized it and thought about it is, let's take SQL, because SQL is, of course, kind of the most common, data query language that actually exists out there. You have selects, inserts, updates, deletes, those types of actual DML statements that you're going to use to modify and to really work with the actual data. When you look at RESTful APIs, you actually have those exact same things. They're just masked as the actual HTTP verbs themselves. So they're going to be get, posts, puts, and deletes, but they're doing functionally the same things as selects, inserts, updates, and deletes. And as we've now moved towards more GraphQL-based APIs, some of the problems that GraphQL was really solving was that developers, by and large, just got tired of writing very specific interfaces for accessing certain subsets of data. And they just basically said, well, wouldn't it be better if we could just expose this API outward, and then the client could tell us what data it wants in return? And effectively, what we've developed is really a version of SQL that is a little bit easier to expose out to the web and out to different types of developers.
And I think, to your point too, it's not this different version or better version of SQL doesn't mean that we should then immediately start thinking of SQL injection, because it sounds more like that tie together of here are all the clever ways of just exploring the data. And we established that you might have an identity, but do you actually have an authorization to explore the data? And I'm going to guess that's where some, here be dragons, because especially if we're talking about microservices, where are the controls? And do we have some transitive trust issues between a bunch of these microservices that microservice A trusts B, therefore B just says, oh, you asked for this data? Sure, I'll give it to you. But they're not necessarily doing it at the granular user level to figure that out. So, I think that's kind of the direction you're going here. Tell us a bit more about, how you see the good and the bad, if you will, of GraphQL and where those dangers are.
Yeah, so I think for at least externally exposed GraphQL APIs, it's relatively easy to think about kind of the threat model of, well, we have to be very careful about what type of data we're exposing here. The way that GraphQL allows you to really compose your queries, and specifically asking for not only subsets of data, but effectively joining other types of data together. I mean, one of the major benefits and problems that it was solving was, instead of me having to basically make 5 different requests to fetch, all of these different resources and then basically do these joins locally on the client, you could basically go and just say, well, wouldn't it be better if the client could just ask for and try to do these joins directly in a single query and reduce the number of HTTP calls and data that we have to transfer back and forth? And so for those types of externally exposed applications, I think a lot of times developers will at least take I'm hoping they'll take a little bit better of a kind of put their hacker hat on, and think about, okay, what are the ways that this can be really abused? The bigger problem, though, is when you start getting to those internal APIs, because generally speaking, there's that implicit trust always around anything that's released internally. And people just start going, and developers will expose them to the various teams around the organization. And they'll basically say, great, here's this interface, this GraphQL API that we wrote out or that we built out. You can go and you can access all the customer information. And, for the business team, they can go and query the data without really having to go and bug the dev teams. And now what this ultimately means, though, is we've taken really kind of like a SQL-like interface. We've exposed it internally only, but at the same time, there's no better controls, or there's no controls really over the amount of data that can really go and access that. And so I think this is where, we talk about the good, the bad, and the ugly. This is where I think we get into that ugly category of, if we look at large data breaches that have happened in the past, where we've had, millions and billions of records really stolen and exfiltrated from organizations, those, generally speaking, have come from databases or, data lakes or those types of systems, or even, file stores. GraphQL APIs, I think, are really kind of that hidden, almost like the really, really big bomb that's just waiting to go off in a lot of internal organizations. And I'm going to call it right now, because we're getting into prediction season, that we're probably going to see a very, very large internal GraphQL data breach, because credentials get stolen, they get access to that data, and then ultimately we're going to have the ability for an attacker to just get in and basically pilfer data through the interfaces you've exposed.
Now, in the spirit of trying to defeat your own prediction, are there ways that developers can turn to try and make this situation better? And here I'm thinking of, we talked a little bit about authentication, talking about JOTS, OIDC, SAML. So there are common frameworks. There are, some standards, some protocols that are, I'll say, relatively easy to adopt, if not necessarily understand, and, implementation mistakes happen. But what about the authorization side of that coin? How can a team go in and not be the one who ends up on Peter's prediction for 2022?
So there's a couple things on the authorization side, and authorization is its own big topic. I mean, it's really challenging, I think, for a lot of organizations, because authorization lives so closely to the business logic of the application itself. And so ultimately what ends up happening is pretty much every single development team rolls their own authorization system. Most of them start with very, rudimentary and crude systems, just based on, we've got these different roles of users, and they'll use standard RBAC. A little bit more, up and coming models, or at least models that are more mature, are going to be more attribute based access control. In particular, though, I think one of the big things that I've seen over the last couple of years has been the development of really kind of open source authorization frameworks and systems, as well as even publications from other organizations that have talked about exactly how they built their authorization systems. And a couple of the big ones that I'll throw out there right now are, there's a language as part of the Cloud Native Computing Foundation called Rego, or it's part of the Open Policy Agent, so OPA. And this is maintained by a company called Styra. And it's an excellent way of basically building out a resource-based authorization system. And it allows you to basically implement this authorization check logic in a variety of different purposes as a library or as a proxy in front of the code, or even in instances where you're running in kind of a microservices environment as a sidecar. There's a couple other languages out there. Another one is called Polar. It's developed by a company called Oso. Smaller startup, but I'm starting to see a lot of chatter about it on Stack Overflow and the various other developer systems. So kind of cool to see those types of systems being built out more and exposed, because being able to centralize those authorization systems, being able to use a framework that's actually well architected is really kind of a big battle with that. If you want to talk about really good architecture of authorization systems, Google, they've published papers on Zanzibar, which is their internal system that they use across all of Google to basically manage authorization across, Google Docs and everything else that you basically touch in there. It's a really, really fascinating read on how to build and actually create an authorization system at scale.
That's interesting. The OPA one in particular is like, so from my container background, I'm used to seeing OPA. First, I was seeing it used to actually, control access around whether a container should be allowed to run in a Kubernetes cluster or not. Mm-hmm. At my last gig, we were using OPA to actually write some of the rule set. Well, the rule set policy which we were using around scanning clouds and ISE. Mm-hmm. So it's interesting in that OPA itself is, while I think a lot of us think of it in one of our particular little boxes, they've actually done a good enough job with the language it can be used across many of these things.
Yeah, it's abstract enough that it actually is able to be applied to all of these different use cases, which is what I think is actually the genius of it itself. And even on their website, or in the OPA documentation, they talk about some of the use cases of how you can implement it for protecting HTTP-based APIs. And while, some of the companies and the main backers, they were more focused on container security and orchestration and, the Kube API actually in a lot of instances, it can be used and extended for these other use cases, which is great to see, and I'd love to see more of it. Probably the most popular talk that I've seen around this was Atlassian actually implemented their authorization framework using it. And there's a couple of videos that are out there, and they were reaching some pretty impressive scale based on the back of it. But ultimately, from a high level, when we think about what they implemented, it focuses really on four main things. You've got a principle, so basically the person that's trying to do something, the action that they're trying to perform, so kind of like those get, post, put, delete verbs that we were asking about or talking about before, which is really just CRUD operations, the resource that's being trying to access, and then as well as any conditions that need to be applied to that. Like this person can only access this from maybe the United States because we've got geolocation requirements for it.
And all that sounds like as well that it's building up the case for call it policy as code, since everything is now something as code these days. But I've been slightly facetious, but to reach the scale that you're talking about and to be able to lint it, just be able to query and say, have we over permissioned something? Hopefully, it's a lot easier to reason through if we've got those four principle or those four components in expressing this language. So I'm kind of curious too. Where was my brain going? Just in that aspect of seeing how where does AppSec come into this? Because a lot of what we've described actually is the DevOps team making those design choices, those architecture choices. We're going to go with microservices, GraphQL to tie them together. That has a lot of performance, a lot of very positive, can reduce latency, a lot of just very good engineering principles behind it. But AppSec can come along and say or do what? Is this a great case where AppSec is actually strong on the engineering and they're going to help just implement OPA, for example, or is there some other type of role for them to come on and help this type, the API engineering?
Yeah, I think if you're an AppSec team and you come to the engineering team and you basically say, let's go and swap out the entire authorization system of our production applications, and the app engineering team's not really looking to do that project at this given time, they're going to kindly tell you to GTFO basically, which it's a huge undertaking, which is why organizations don't do it. So, but there are things that you can do kind of ahead of time, and I think if we go back to kind of this notion of API security really kind of being a data security problem, for an AppSec team, I think what you can do is you can start to apply some of your data security types of practices to your APIs, and that's going to actually get you there, at least from kind of a understanding what your attack footprint looks like, understanding at least if someone is trying to access too much data. And really where that starts is by understanding not just what your attack surface is and the data that's going over it. So kind of that discover and classify kind of aspect of your data security programs, but then taking it one step further and saying, well, let's start auditing all of our API queries that we end up seeing. And, in the case of a RESTful API, they're probably going to all look very similar, and you're going to be able to really kind of throw away a lot of it, or at least kind of batch a lot of it. But when you start getting into GraphQL APIs, especially where they tend to be highly irregular or custom, basically, depending on the type of resource that's being requested there, this gets you a really far along in the process of at least understanding how resources are being accessed, who is querying what data. And then in particular, I think when we think about data security, one of the most important aspects is always, if I'm auditing a SQL database and I want to know if anyone is performing any malicious SQL queries or trying to expose or extract large amounts of data, probably the most important thing that I want to look at in there is the number of rows returned. I want to know how many records are coming back. And you can do the exact same thing looking at it from a GraphQL perspective, or even a RESTful API of understanding how many resources are actually being returned with each individual query.
So the OWASP top 10, for example, I think had like an insufficient logging, which is a reasonable recommendation, an observation about things that can go wrong, but it's also unfortunately pretty high level and tends to be so vague that it's hard to say, okay, well, what does sufficient logging look like? And I think you just described a couple examples of what sufficient logging should be, but are there ways too, if we, as the AppSec person coming into the room, I've already said and failed perhaps to say, oh, we're going to adopt, Rego. We're going to recreate the Zanzibar model, and not going to accomplish that in a quarter's worth of engineering effort. Can I come in and do something similar with, being able to have some better traceability or auditability within the application?
Yeah, and this is, I think, the great thing is, as the security team, you can come in the room and you can start advocating for observability tools. And you're going to get the DevOps guys over there, and their ears are just going to light up, and they're going to say, yes, we've been, clamoring for observability tools for, years. And this is actually one of the great things, improvements. We want to talk about the good of API security. This is one of the great things that I think has really evolved over the years, is the improvement in observability tools and the open source kind of, or at least, standard frameworks around it. So you have part of the CNCF as well as you've got things like OpenTelemetry, which by and large, most of the community has kind of really kind of started to go and focus on. And while it was originally designed more for let's troubleshoot and understand where there might be latency or bottlenecks in our microservices architectures, one of the great added benefits to it from a security perspective is it basically implements full data tracing across the entire request. And you're able to understand not just what those requests are doing from a latency perspective, but also really from like a data lineage perspective, which APIs are effectively being called by individual front-end requests. And so by having that and those tools, that data can give you that audit trail that you really need, at least initially, as you're looking for it. And then you can start, of course, going and implementing your own custom, middleware or resolvers, whatever you want to call them, depending on the type of framework or API that you're working with, to give you more data. But it's a really, really good starting point, I think, for a lot of organizations.
No, and definitely a better story. I love how you put that in the sense that this is something that's already going to help the engineers. And oh, by the way, if we do this one more thing, or if we just broaden it a little bit, we're going to get some great security benefits out of it too. Sounds much more, much friendlier way and more successful way of approaching that.
Absolutely.
So I think you've talked a little bit about the future. We'll possibly see that big data breach from compromised tokens. We've, I think to help bolster your case for that, we've also seen recent supply chain attacks that have targeted environment variables because that's where the tokens are. So, it doesn't necessarily seem like you're, going too far out, or we won't necessarily be too surprised by that. Looking ahead, or maybe even for that matter, looking to the past of things we could learn from, are there other aspects you'd really want to highlight, or, as cautions for, or things to learn from, or to try to accomplish for teams that are diving into API security, and hopefully from a fresh perspective, or trying to, even if they're trying to get away from legacy applications?
Yeah, ultimately, I think one of the biggest things that I just want to emphasize is, and we talked about this very briefly in the very beginning, is if you're going down this path and you're just saying, okay, APIs, we've really got to get our hands around it, the very first thing is don't throw away your entire strategy. Like I said, about 70% of what you're doing for web application security will still apply for API security. You just kind of have to cover this new 30% gap. Some of those things will be, fairly straightforward and not that difficult to really manage. So great examples are, one of the things I strongly advocate for is if you're developing RESTful APIs, one of the great easy things you can do is starting to advocate for design by contract. And so basically what I mean here is if you think about APIs are interfaces, and one of the big things that developers love talking about is really coding to the interface or treating your interfaces like a contract. And if you think about how you expose those external APIs out, one of the great things is a lot of times now there's going to be specifications or schemas that are really kind of associated to it. And the most common is going to be the Open API specification, or previously known as Swagger. And so a great strategy that you can use to implement not just really good development hygiene, but also really being advantageous to do kind of that input validation type of aspect is to do more of a design by contract based on that schema. So as an example, at Imperva, what we do is anytime an API needs to be exposed externally, it has to be documented first in the actual schema. So the developers have to have that really good, robust documentation that is always forgotten or an afterthought in order for us to actually expose that API out. If it's not documented, then it doesn't get exposed. That's pretty much where we stand.
Yeah, I'm laughing because it sounds like a good point that I forgot about, the idea that, well, this will just be an internal API, and a couple months later, there's a product decision to say, hey, this is a great B2B SaaS API. Let's expose it. And oops, we didn't document it, or we didn't do something like that. I'm curious, are there some other cautions? Help jog my memory, or help me expand my list of, are there other things that should be careful of on that internal, call it that soft, crunchy interior of APIs?
Yeah, we talked about it just very briefly here, but ultimately it's not just understanding the attack surface, all the APIs that are out there, but it's really also understanding the data types that you're exposing. In particular, I think APIs always tend to be overexposing data. A lot of times, especially on the internal side, developers will go in and they'll basically expose an API and they'll say, we're going to give access to all of this data because it's only for the internal applications and they might need it later. And I don't want them to come back to me and, ask me to change this or add some parameters or fields or things like that. And so they just, expose lots of data. And then, like you said, 3 months down the road, someone basically just says, well, great. Well, let's just go and expose this API out externally. And sure enough, we started exposing lots of PII or EPHI or, all the different types of sensitive data that you might have out there. And so those are really the kind of those bigger risks that you have to think about, really kind of from a risk management perspective, is what are the actual data types that we're exposing? So not just what are the API endpoints and where are all their APIs, but also understanding that sensitivity of the data helps you to basically make those decisions and better understand when something inadvertently becomes exposed externally. Because if you go through kind of some of the big data breaches that have happened in the last 2 years related to APIs, that's probably one of the biggest ones, actually, where sensitive data was just accidentally exposed out through public APIs.
Yeah. Now I know we've unfortunately passed. October's behind us. But still, speaking of ghosts and goblins or things of the supernatural, you're talking about a lot of the API security as a data security problem, and what you're just describing sounds a little bit like having a data inventory or even a data flow diagram, which once again are easy to describe, but are these creatures, have you seen these creatures in the wild? Have you seen teams successfully develop these though?
I'm going to say yes and no. I'd say, like any other kind of like inventory or asset inventory, there's always kind of like well-meaning and well-intentioned efforts, and it's always ends up being about like 80% accurate. And unless you're really kind of more proactively keeping up with it and basically regularly scan, not just treating it as a point thing, or you're taking an approach where the only way something gets exposed externally is we do have the documentation and it's basically fully uploaded, and that's kind of our gating principle, then there's a good chance that it's probably not going to be up to date in there. We do see more and more people kind of exposing and building out centralized data catalogs effectively for at least RESTful APIs, because one of the big challenges, of course, with RESTful APIs was that, unless you had access to that documentation, you were basically, just pointing at a black box and trying to guess what the parameters and resources were. And so there are lots of developer tools out there where now they're kind of decentralized API instances. Like, probably the most common one that people will be using is like Postman, just to be able to share the collections out and things. But the accuracy of those, because a lot of times they're going to be based on what developers wrote, is going to be a little bit suspect.
A little bit suspect. That sounds like that should probably be a theme of application security. Quite honestly, maybe that'll become our motto. You've made one prediction already. Looking again, do you want to add to that predictions, or just looking forward? Do you instead of a prediction, perhaps a preventative measure that you'd love to see teams adopt, or something that they should just keep their eye out for as 2022 starts to roll in?
I think ultimately, as more and more organizations are at least making, there's a greater level of awareness, I think, around at least like these types of issues with APIs and the challenges that teams are facing. I think the technology and the tools, especially for security teams, are getting a lot better at being able to detect and understand that. And, in particular, I'll even say it from Imperva's perspective, when we started looking at and thinking about API security really through that lens of data security, we kind of realized, oh, wait, we have all these other algorithms that we built for, detecting bot traffic or detecting data breaches through a SQL database that can actually be applied to some of these problems. And so I think from a defense perspective, the technology is getting a lot better and there is more hope. So you don't have to go and implement and try to build this stuff from scratch. But ultimately, it's really going to be just a matter of teams kind of getting started on this journey and thinking about really kind of the new problems that they have to go solve with API security. And it can be a bit challenging, I think, or daunting for a lot of teams, especially if you don't come from this world of being an API developer and really understanding kind of the nuances of them.
No, I think that's and that's a great way. We'd love to have you back. So when when that big internal data breach happens, hopefully it won't happen until 2022. But who knows? We'll definitely have to have you back and chat with us about that and do some analysis and once again a constructive postmortem about how teams can better protect their APIs.
Thank you. Yeah, I would love to be back to chat about it and just go take a look at some of the bug bounties that get posted out there. And I feel pretty confident in my prediction just based on what I've seen out there already.
Well, I feel pretty confident that we've got some great information just now about securing APIs. So I just want to say thanks once again, Peter. I want to thank John as well and everybody who's been listening. If you'd like to hear some more insights from Peter, go check out episode 159 back from July 26, 2021. And if you'd like to learn more about Imperva, visit securityweekly.com/Imperva. And with that, we need to take a quick break and then we'll return with news of the week.